Hello student, today my lecture topic on diffraction grating. In a previous lecture, we have derived the angular width of n slit. All of you know that the angular width of the n slit is known as 2 d theta is equal to 2 tan theta n divided by, here the n is the order and n is the number of the slit. And also you know that we can write that the condition for diffraction is a plus b sin theta n is equal to n lambda, and also we can write that n is equal to a plus b sin theta n divided by lambda. We can put the value here, you will get that tan theta n is equal to n a plus b sin theta n well lambda here. Now you can solve this relation, you will get the answer 2 lambda is divided by n a plus b cos theta n. All of you know very well. Yes. Now you can see here, you can see that first we observe that here effect of closeness. What is the meaning of the effect of closeness? It means that when a plus b, the value of the a plus b is decreases, here you will see that the width of principal maxima will be increases because both are the inversely proportional. And the first point, and second observed point is effect of width of ruled surface. What is the width of the ruled surface? The width of ruled surface is NA plus B. It means that when NA plus B is increases, you can see that when A plus B decreases, it means open and closed portion will be decreases. It means that number of the slits will be increases. Overall, NA plus B increases. It means that the angular width will be decreases because this is inversely proportional to these values. Okay. Now, what is the advantage of this? The advantage of this, third one is, what is the advantage? Third point is advantage of increases the ruled surface. It means that the advantage of the ruled, increasing the ruled surface, it means that number of the lines is increases in a grating. You will see that what will happen when n is increases. You will see that the intensity of the principal maxima, all of you know that, is proportional to the n square, and the ratio of the secondary maxima with principal maxima is proportional to 1 upon a 1 plus n square minus 1 sine square gamma. Now here you will see that this intensity ratio will be decreases when n is increases. It means that here you can see that suppose that n is equal to 2. When n is equal to 2 in 2 slit, you will see that n minus 1 is number of the minima is equal to 2 minus 1 is equal to 1, and n minus 2 is equal to 0. Secondary maxima, you will see that here like a principal maxima like that, both side here like that. It means that here the value of principal maxima is n square, here is 4. Okay. Now when you will increase the number of the slits, suppose n is equal to 3, n minus 1 is a minima, is 2 minima, okay, and n minus 2 is secondary maxima, will be 1. It means that here, like that, here, you will observe when in case of the, like that. Here I plot only interference pattern, not diffraction. Okay, you can see that here, here you will observe that here, what will the intensity of pixel maxima? N square is 9. You will see that intensity will increases, and here you can see that as compared to this one, the secondary maximum will be appear here. Now when n is equal to 4, in this case n minus 1 is minima 3 and n minus 2 is maxima 2. It means that here you will observe that intensity will be increases as secondary maxima intensity will be decreases, like that, here, like that, here will be 16 because n square, here will be 16, and now intensity will be decreases because of this ratio. Okay, suppose n is tends to infinite, it means that number of the slit more than, like that 10,000, 20,000, 50,000, like that. In this case, you will see that here, like that, the intensity of the principal maxima is more and secondary maxima almost disappear, like that, disappear like that. Here n is equal to 0, n is equal to 1, here is minus 1. You will see that here that the secondary maxima is disappear. Where n is equal to is very more, the secondary maxima disappear, and this type of the spectrum we will get in a grating. Here this type of spectrum we will get in a grating. This is the advantage of increasing the ruled surface. It means that when the increase the number of the slit increases, you will see that the secondary maxima almost disappear, and okay, fine, there is a main difference between the n slit and grating spectrum. In a case of the grating, we will not see any secondary maxima. Okay, now the third point is effect of order. Here you can see here, in this case here, you will see that when here you can see the order is inversely proportional. It means that order is increases, width will be, order is decreases, width will be increases, vice versa. Order is increases, width will be decreases. Okay, and now effect of wavelength. Fourth is effect of wavelength. The effect of the wavelength, you can see here, you will see that is proportional to these values. It means that lambda is increases, 2 d30 to be increases. All of you know that violet light have a less wavelength as compared to the red light. It means that the width of violet will be less than as compared to the red. Okay, here, and also now fifth is how to measure the grating element. The value of A plus B is known as a grating element. All of you that suppose n A plus B rule surface into 1, where n is number of line per inch. The value of the A plus B is 1 upon n in inch. In a centimeter, A plus B is 2.54 n in centimeter. You can measure the value of grating element like that. Here n is given in the grating, and from the grating you can calculate the value of the grating element. Okay. Now again we will discuss what is the missing order. Missing order. Missing order. What is the missing order? Missing order. The angle of diffraction theta having a value such that the minima due to diffraction component and principal maxima due to interference component in intensity distribution fall at same position then that the order of principal maxima will absent. This phenomena is known as a missing order. You can see here the angle of diffraction theta, the value such that the minima due to the diffraction minima and the principal maxima due to the interference intensity distribution fall at a same position. It means that all of you know that condition for principal maxima is all of you know that a plus b sin theta is equal to n lambda. This is the principal maxima. Principal maxima, it will come of interference. And you know that the condition for minima b sin theta is equal to n lambda is a minima come of the diffraction. Condition when both angles are the same, this theta will be same. It means that we can write that a plus b upon a v is n upon a m. N is come to the interference. Here will be minima. Here is m is the order of minima. Here is the order of our maxima. You can see here. This is the you will get the relation like that. Suppose that first condition a is equal to b. It means that here will be the opening and closed portion. This one a, here will be a b. A is equal to b. In this condition, you will see that here b plus b upon a b is equal to n m. You will get n upon a 2m. Okay. Here, suppose m is equal to 1. It means that m is equal to 1 means that diffraction minima you will see that 2. The principal maxima lies at m is equal to 1. It means that suppose that here suppose that we have a number of slit n is equal to 4. Suppose that n is equal to 4 is n minus 1 is a minima, 3 n minus 2 is equal to 2 minima. So you will get that the intensity here like that, here 1, 2, like that, here like that, here like that, and the diffraction, now the diffraction pattern is like that. Here m is equal to 1 and n is equal to 2. It means here 0, 1, 2, minus 1, minus 2 here. You will see that m is equal to 1. Suppose that it means that the principal maxima lies on here like that. This is the diffraction pattern like that. Yeah, this one, this is a diffraction pattern. This will be a sine square beta upon a beta with respect to beta. This one is the sine square n gamma divided by sine square gamma with respect to gamma. Here you will see that finally the spectrum line come here like that. Like that. Here like that. This is plot of sine square beta upon a beta square multiplied by sine square n gamma divided by sine square gamma. All of you know that the diffraction pattern behave as an envelope on interference pattern. And also you can see that at the missing order, the second order of principal maxima, here you will not see in a Grating or in a spectrum or a n slit. Okay, fine. Similar for other value of a and b. Suppose here a is equal to 2b. Here 2b plus b upon a b is n by m. Here n is equal to 3m. You will see that at this condition, m is equal to 1 and is equal to 3. It means that third. Suppose n is equal to 4, so 2 will be here, third will be missing. It means that in this spectrum, in a diffraction envelope, we will see that n is equal to 0, n is equal to 1, and n is equal to 2, but 3 will be missing at this condition. Okay. And another important point, what is the overlapping? Calculate yourself like this. Suppose that I am giving a question like that. Suppose n is equal to 4, the fourth slit, and also I am giving that b is equal to 0.004 centimeter and d is equal to 0.0132 centimeter and lambda is equal to 6.28 into the power minus 5 centimeter. Lambda is equal to 3. Now here you can see that here I am giving for example here, as per the missing order, all of you know that a plus b upon a b, n upon a m. Now n upon a m, here d is, all of you know, a plus b, here the value of 0.0132 divided by 0.0044, you will get the value is 3, almost 3. It means that m is equal to 3m. It means that at m is equal to 1, n is equal to 3. 3 will be missing in a spectrum. Here. And also you can check also from these values here, a plus b sine theta is equal to n lambda for interference condition, n is equal to 1, theta is equal to 27.27 degree. and n is equal to 2, theta is equal to 0.55 degree, and n is equal to 3, theta is equal to 0.82, and 3 will be missing. Okay, now b is equal to sine theta m lambda. This is a condition for diffraction minima. Now here m is equal to 1. You will see, and also you will check it. Theta is equal to 0.082. You can see here that the value of this n is equal to 3, both will be the same here. It means that this will be a missing on a theta scale. Okay, it means that n is equal to 4, like that, n is equal to 4 here. Like that, suppose that I am plotting one portion only, 0, 1, 2, 3. Now when in a diffraction pattern like that, here it will be appear, suppose here 2, like that, here, and it will be disappear, and the angle is 0. This one is 0.27 degree, this one is a 0.55, and last this one is a 0.82, because both have a same angle, and also you can check from here this relation missing order. Okay, now another example, what is the overlapping? What is the overlapping? Overlapping. In overlapping, basically we will see that, for example, all of you know that condition for diffraction a plus b sin theta is equal to n lambda. Okay. Now suppose that here like that, here now the value of this one, only this one, mention here when n, here n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, 5 and 6, and the wavelength, suppose that 0, this one, and 5 to 50 we will consider, and 7000. Here we will consider the wavelength in the range of the visible. Here the lowest wavelength is the maximum wavelength. Here the in between any wavelength. Okay, fine. N is equal to 1. The value of this one is 4200. N is equal to 2. The value is 8400. N is equal to 3. Like that. N is equal to 4. Like that. N is equal to 5. Like that. And n is equal to 6. Like that. And now here n is equal to 1. The value of this one is 5250 to 00. Like that. N is equal to 3. 0, 0, like that, and n is equal to 4, 0, like that, and n is equal to 5, 0, like that, and n is equal to 6, 0, t 0, 5 and 31. Now here n is equal to 1 is 7000 to 40,000, here 21,000, and here 28,000, 35,000 and 42. Now here, okay, fine. You can see here, you can check it here yourself. These values, this one is same, like that. It means that the spectrum of this wavelength of third order will be overlap of this wavelength of fourth order, and also this wavelength will be fifth order. It means that the shorter wavelength of higher order is overlapped with longer wavelength of lower order. Here you can see that here, and also again you will see that here that the order 1 and 2 is never overlapping. Here you can see that these values never overlap. These are two important phenomena we will see in a diffraction grating. One is the missing order, other is overlapping of the spectrum. Spectrum can be missing, can be absent because of missing order, and also we will not see any spectrum due to the overlapping also. So both effect is very important in case of the diffraction. Now we will discuss the formation of spectral line with grating. We will discuss the formation of spectral line with grating. What are meaning formation of spectral line with grating? All of you know that condition for grating. All of you know that A plus B sin theta is equal to n lambda. The first condition, all of you know that violet light have a low wavelength, like that. It means that the diffraction angle of violet will be low as compared to the red light. The first condition is like that. And also the number of the order. N is 1 and n is equal to 2. It means that when the order is increases, angle will be also increases. Suppose that here we have a grating here, like that. Here is a grating, like that. When a white light incident on a grating, here will be axis normal incident. Here when n is equal to 0, third point is n is equal to 0. Here will be the white light, so that all the wavelength is coming here. It is also a bright white light. You will get a white light here, spectrum here, because n is equal to 0. All the wavelength is here, like that. And from the axis here, suppose that here n will be first order, like that. N is equal to first order. Here will be a theta violet. Here will be red. It's a violet spectrum. It will be red spectrum. Like here, because of symmetrical nature of the grating, theta V violet and theta R here, n is equal to 1. This is a violet. This will be a red, like that. Red, like that. And all of you know that the second order. In a second order, theta will be increases, like that. Here you will get this is a violet, red, and is equal to -2, -1. Here n is equal to, like that. Here V and R, this will be the angle theta V. This is the angle theta R, like that, and is equal to 2. Here also is theta B and theta R n is equal to -1. Here you can see that here. This is the spectrum like that in a grating. Okay. Now question is, what is the maximum order is present in a grating? How you can check the maximum order present in a grating? The maximum order in grating. How can you check it? Maximum order, या maximum order spectrum in a grating, या maximum order in a grating. It means that all of you know that A plus B sin theta is equal to n maximum. N is maximum when theta is equal to pi by 2. It means that n maximum, it means that A plus B is equal to lambda. First guess, when A plus B is less than 2 lambda, the value of n maximum is equal to less than 2. It means that you will observe only 0th order and first order. Okay, and when A plus B is less than 3 lambda, n maxima is equal to 3 lambda. It means that you will observe 0th order, first order and second order only. This is a condition for formation of the spectrum in a grating. All of you know very well what is the meaning of the missing order. Also you know that what is the meaning of the overlapping, and also you can calculate the maximum order in a grating, and also you can calculate the grating element. What all of you know very well what is the ruled surface, and also you can draw any spectrum from n slit to grating. Okay, stop here, and in coming lecture we will discuss the resolving power and also the resolving power of the grating. Thank you.